This
Kenya.
conference will now be recorded.
Oh, thank you.
Yeah, I just turned the recording on so we can share this later. But
Yes,
go ahead and start over if you would.
Actually, we had requests for that, and I forgot to ask you about it.
I just forgot about it myself. All yours.
Yeah, thank you. So, as I was saying, my name is Moshiri Nyaga. I'm with the Local Development Research Institute based in Nairobi, Kenya. We host the Africa Open Data Network, which we host and convene, and we are also co-conveners of the Big Data for Development Network, together with our colleagues in Kigali at the Africa Institute for Mathematical Sciences. We're very delighted to be able to do this. So just a little bit of a background. The Africa Open Data Network is part of a global network of what we call nodes that focus on bringing open data to bear on development in the global south. And this is known as the Open Data for Development Network, or OD4D. So AODN, the Africa Open Data Network, is the Africa node, one of the Africa nodes. We focus more on the sub-Sahara Anglophone side of the continent. We have colleagues based in Burkina Faso who run a node called CAFDO that supports open data in Francophone countries, and our colleagues at the American University in Cairo at the Access to Knowledge for Development Center there, who hosts the Middle East and North Africa node. Our work is essentially to explore how open data can support development efforts on the continent, but also to support the institutions and the actors, whether they're in government or outside of government, who are working to make data open, to make it usable, and to make it relevant for the work that everyone is trying to do on the continent, whether it's civil society, government, or just citizens and the media. The Earth observation and the broader satellite data conversation is very important for us, because it allows us to have access to type of data that we would normally not have easy access to, and allows us to make the kind of decisions that would probably require very expensive surveys and possibly censuses in order to get the kind of intelligence we need, whether it's agriculture, deforestation, whether we look at water resource management, or even the complex issues of urbanization. So we found that the Africa Regional Data Cube was actually quite relevant for the work that members of the Africa Open Data Network community are looking at. And even for those working on big data, this is essentially one of the sources that are available to the community for this work that we're doing. So that explains why, for us at the Africa Open Data Network and BD4D, that this becomes such a big priority for us. So we're also delighted that we're able to collaborate with a global partnership for sustainable development data, which you'll hear about in a few minutes, to get this done. And we're looking forward, of course, to collaborating going forward on actual use and uptake of the data cube, and possibly also coverage beyond the 5 countries to 55. Can I hear an amen, Davis? So we're looking forward to that. So I think maybe what I'll do now is hand over to Davis before we go into the nitty-gritties of the Africa Regional Data Cube. Maybe Davis can give a little bit of a background on what the Global Partnership for Sustainable Development Data is, and a little bit about how the data cube came along. Possibly, I don't know if Brian, you could cover a little bit of that so that people can have some context on where we're coming from. So over to you, Davis.
All right, thank you very much, Mushiri, and thanks to everyone who's really created time to be part of this webinar. We really appreciate you taking your time to join us. The Global Partnership, my name is Davis Adiano. I'm the Regional Director for Africa, the Global Partnership for Sustainable Development Data, which is a global network comprising over 325 members across the world, including national governments, multilateral organizations or agencies. We have civil society organizations. We have a large private sector, small private sector entities. We have research academia and many other organizations who are primarily focused on how data can support the sustainable development goals in the first instance, but we do recognize that when it comes to the national level or the regional level, for example, in Africa, we have Agenda 2063. In different countries, you have visions that guide national development priorities. So it's primarily sustainable development goals, but secondly, looking at sustainable development overall, and how data can be central and drive that as a key lever to eradicating poverty and tackling some of the major global challenges that are facing us, climate change, environmental issues, and many others. Really, for us, our main concern is, that governments, NGOs, UN agencies proactively think about investing in technology, in relationships, and people, and that the right data is actually available at the right time, and that data is actually used to make decisions that then drive progress that has an impact or bearing on people's lives, and that different institutions do have the data they need to make investments that promote sustainable development. So for us, as a partnership, really, we work at different levels: global level, regional level, national level, and work with partners who work at the subnational level to look at how data ecosystems can be developed that bring together all these different parties within the national statistical system, but within the broader and expanded mandate of the national data ecosystem, where you're not just thinking about government entities, but bringing in other stakeholders who are proactively working on data-related issues. And I think what we think and what we know, I think from what we are learning, is that the investment in institutions is quite critical, and the investment in systems is also critical. And the more we can partner or connect the dots amongst different entities, the better the chances for us to leverage highly diminishing resources, and also ensure that we build blocks that drive change at different levels, because we can't do it alone. We have to rely on partnerships with Mushiri, with NASA, and many others, in a way that then supports change makers within existing systems in the private domain or public domain, and of course create opportunities for sustained change. And of course, we also proactively think about creating incentives for political change. And this is because we believe we have to safeguard public interest and drive progress at scale. And of course, governments are leading in many aspects in this area, and what we want to do is to support them in the production, sharing, and using of data. And I think from just having mentioned all that, the partnership for the Africa Regional Data Cube is more or less centered around this broad thinking of connecting dots amongst different entities, both global, national, and of course regional. And of course, this is in response to calls from our country partners through 2016, 2017. we heard from our partners in Kenya, in Tanzania, in Ghana, in Sierra Leone, and Senegal, because those are the countries where we primarily focus at the moment, but many others, that there's actually need for more usable Earth observations data that can provide insights that can then be used by governments for decisions, either in agriculture, environment, or any other sectors. So in response to this demand, the partnership between the Global Partnership for Sustainable Development Data, the Group on Earth Observations, NASA, the Committee on Earth Observations, the European Space Agency, Amazon Web Services, the Kenyan government, Strathmore University, to launch the Africa Regional Data Cube in May 2018 was basically to think about how we can leverage the Open Data Cube infrastructure that has been developed by the Australian government and successfully tested in terms of providing open source Earth observations data to for different sectors. And after we launched in May, we thought, we realized that there's a lot of need for capacity building. And of course, Brian will talk about it. He's been conducting virtual trainings for different government partners, but also at the national level, proactively thinking about policy and legal aspects. What are the key barriers? What are the people's fears? I actually met someone about 2 months ago who asked me, you have launched this Africa Regional Data Cube. What exactly is it going to do? Now, are you guys going to be able to see me as I walk into my compound? Are you going to be spying on me? So, the real and perceived fears amongst different stakeholders when it comes to these kinds of technologies. And of course, our role is to simplify the language around it, but also demonstrate value and the utility of this data in supporting sustainable development. And this is what the Africa Regional Data Cube has been all about. You have the infrastructure in place, you have with the right partnerships in place, then it is actually possible to leverage technology to make it easier for different stakeholders to access this kind of data. But more importantly, it's not about just making the data available, but proactively thinking about its practical utility at the national level, at the subnational level. What are people's priorities? What are the data gaps? And what is it that they're actually looking for in terms of trying to plug those data gaps? How can we make data that used to take 6 months to process, for example, be accessible to someone within 15 minutes, and that they can actually conduct analysis using preset algorithms that have been tested elsewhere and that are being tested and developed, because the capability of the ARDC is to include other tools and methodologies that are being tested. And of course, Brian will speak broadly to how we are proactively thinking about radar data, and of course, integrating population data into the ARDC. So layering this data and of course using it to complement many other sources of data is what we see as the greatest benefit. You can investigate a case primarily from the ARDC, and then you can more meaningfully conduct further investigations or apply different resources within either government or the private sector in a way that allows you to target better, be more efficient, and of course save on resources and time. So I'll pause there for now. I didn't deliberately go into the model of how the ARDC works because I believe Brian will cover that, but we do have some time, and I'll be more than happy to delve deeper into that in case there are any questions. But happy to be with you all, and looking forward to hearing from you what questions or concerns you have, but also learning from you where you think this data could be applied. One of the other aspects that I forgot to mention is that moving into the next year, we are thinking about proactively building data communities around the Africa Regional Data Cube. But even as we think and learn from the Africa Regional Data Cube and what it's actually delivering for countries, and they're very meaningful, sometimes even painful lessons that we are learning. All this is going to be applied as we think about scaling across the continent through Digital Earth Africa. which brings together the consortium of the same partners who launched the ARDC, but bringing in new partnerships and thinking about more networks and diverse data stakeholders who may be interested and who believe that this data could be of value. So as we scale towards the region, to cover the entire region, it definitely means more work, more challenges, a huge demand for the data. How do we effectively respond to that? And of course, all of you being part of this call means that we can well in advance start thinking about how we can not only engage with the data, but also be part of a broader network that's promoting the use of satellite data and, of course, its interoperability with other data sources. Thank you.
Thank you very much, Davis. This is one of those opportunities that we get to see at the very beginning, where 5 countries covered so far, but then we'll have a front row seat, not just to spectate, but to actually be part of the work in seeing this resource scale out and become available to the rest of Africa. So thank you very much. Just a little bit of housekeeping. As the webinar goes on, and just because we might have questions that we might not have enough time to let everyone ask their questions, I'll be suggesting that we post our questions in the text box in your chat, in your chat box. I'll be on the lookout for those, and we'll be responding to the questions during the Q&A a little later. Also, if you didn't already provide us with your contact details when in the sign up form, in case you got a link to the webinar, from a forward or something like that, please do let me know what do share your email address with me, so that we can keep you updated after the webinar on the next steps and some of the things that we might be looking to do in relation to the Africa Regional Data Cube. Oh, great! There's already a question about me speaking on the data cube. Very good, Joseph. With your question on the chat box. The whole data cube idea, Brian will go into that in just a bit. But then I just also wanted to say one more thing. You can find out more about the global partnership on the website, and the Africa Open Data Network as well on our websites. The links to those are in the chat box now, together with the Twitter handles. So one second. So if you'd like to stay in touch on Twitter or follow us on visit our websites for more information, please go ahead and do that, and that you'll find in the chat box. So I think we can now move on to the main part of the show. Brian, Davis, and I have done all the curtain raising. So we're now going to exit stage left and let you take over with the good stuff. Over to you, Brian. Brian, are you muted?
Oh, I am muted.
Oh,
Thank you.
There you are.
Yeah, that was terrible. Thank you, Machiri. Thank you, Davis. I'm showing my picture here on the screen just temporarily, just to tell everyone that there is somebody back here behind the scenes, and it's a pleasure to meet all of you virtually through this. I see we have a large number of attendees, which is really fantastic. You see the list is moving and growing right along. And as you have questions, feel free to throw them into the chat. So I will turn off my screen here, and I'm going to jump over to presentation. But as Davis was saying, I will reiterate, have no fear. The data cube cannot see you on the ground. We So hopefully everything is good and you will enjoy seeing this. So I'm going to turn off my camera here temporarily. And let me jump on over to my presentation here. And I'll close the screen. Okay, so good morning, good afternoon, everyone. My name is Brian Killo. I work for NASA, but I support something called the Committee on Earth Observation Satellites. This is a recent picture of the organization. We meet annually. And so this group, our primary focus is to coordinate satellite data around the world and to optimize the use of that data from all of the space agencies around the globe, NASA being one of many. So in this international coordinating body, we have 24 countries and 62 members and 163 active satellites. So it's really a tremendous amount of satellite data information that our objective is to get this in the hands of more users around the world. So the opportunity that came before us, which was this African Regional Data Cube, was a fantastic opportunity, and we jumped on that, and I was very, very pleased that we could move forward with this project. So let me show you what all of this means, and we're going to first start with this concept of a data cube, which someone had mentioned in the chat box. So what do we mean by a data cube? The traditional way of dealing with data is to take a scene like a Landsat image, and perhaps there's thousands of those over any given country, and we would grab the pixels out of these individual scenes. Now, these scenes are like 150 kilometers square. They're just a single point in time, and there's many and many of these happening throughout a year for a given area. We pull the pixels out of those scenes and we store those in these things called storage units. Somebody just joined. If you could mute, I hear some background noise. All right, I think we're cleared. Well, I'm still hearing that. I'm not sure where that's coming from. If there's somebody online that just joined, if you could mute your audio. It must be a phone. It must be a phone caller.
Think they can be muted.
I can't mute them. Yeah, I'm trying, but I don't see them on the list. Who's ever, whoever it is. There's a caller
hello.
there. I think that's it. All right, it's quiet now. I think we're good. So getting back to the data cube, if I pull the pixels out of these Landsat scenes, which is the smallest bit of information, like a 30-meter square piece of information, I can stack all these in these things called data cubes, and arbitrarily we put them in a 1 degree by 1 degree latitude, longitude in 1 year, and we build up a stack of these pixels and we put them in these things called cubes. So now we're not dealing with scenes anymore, but we're dealing with a well-organized stack of pixels that there's no overlapping regions to worry about. There's not individual files, but now it's all packaged into one unit that we can access, and we can also compress that data. So now once we have all that information into this cube, it gives us some tremendous advantages for computation, as well as for just generally for computation analysis and for viewing it. So it makes it easier for us to use the satellite data. It makes it easier for us to query that data and to run applications. And everything that we do in the Open Data Cube is free and open software. So all of these algorithms and everything that we're doing is free and open. None of this would be a fee-based across the world, and that's never our intention. So what we're doing in this community with the Data Cube is, it is a community globally. There's a lot of data cubes. I'm going to share with you where they are. It's not just in Africa. They're all over the globe. And this community now is developing algorithms. It's sharing ideas. And we're doing a lot of things together that can benefit not only Africa, but other parts of the world. And when you pull all these things together, you now have efficiencies for time series analyses. I can look at different data sets together. We call this interoperability. So how might I use a Landsat data set and a radar data set together? And why do we do all this? Well, we've shown that it works. Australia started this. They're the, I like to say they're the godfather of the data cube. They started it all. Switzerland was next in line. They're doing some tremendous work, and it's really growing nicely. So where are these things all over the world? Here is our current map. This map shows you that across the world, there's 55 different countries with some sort of interest in data cubes. 9 of these are in operation. 14 of them that you see in gray boxes are coming soon. So this is growing rapidly. It's growing rapidly everywhere. And we're excited to see that if this one single construct can be used in multiple locations, there's a lot of advantages that we can share algorithms, we can share approaches. And when we talk about a problem in one area where maybe like in Ghana and Sierra Leone, we've come up with a algorithm that can detect illegal mining, and that sort of problem occurs elsewhere, we can share those algorithms. So there's a lot of exciting things that can be done here. So how do we use these data cubes? Once we have all this data stacked up in a nice configuration, we now have this ability to apply a variety of algorithms. This is just a list of some of the things that we can do. These are the more common activities. So we have cloud-free mosaics, we have spectral indices, we can classify the land, we've got water, and I'm going to share a number of these with you and some algorithms for land change. So there's a lot of technical jargon here and a lot of acronyms, but don't worry about those so much. But I'm going to share some of these results with you and show you the power of what can be done. And what is really interesting is I've just in the last couple days in preparation for this presentation, I've done a number of analyses over Kenya, and you're going to find those results pretty interesting. So the African Regional Data Cube, Davis did a great introduction. It was launched back in May for the 5 countries that you see listed. We just have Landsat in that cube now. Sentinel-1, Sentinel-2, and ALOS, which are other data sets, they're coming soon. We're in the background preparing those. Probably in the next couple months, all that will come together. So there'll be significant amount of new data in the cube, not just optical data, but also radar now. So there's really a large number of things that we can do now with the cube. It's supported by CIOS, which is the group I work for within NASA. I'm part of this international organization. Amazon has donated cloud service, cloud computing. So all this works on the web. And as you heard from GPSTD, they're involved as well. We've done a lot of remote training. So since we left in May, we have done some training for Ghana, Sierra Leone, and just yesterday, the last 3 days, we were doing training for Tanzania. So many of these countries are now coming to us saying, hey, we need some help. We'd like to run this case or that case, or we have more people that want to learn from this. And there's a number of use cases you see listed there. I'm going to show you some examples. So this first example is water extent. This is a time series view of Lake Baringo in Kenya. So you see on the left there, this is a habitat for many species of birds and fauna. It's the water levels have dramatically reduced due to droughts. And the image you see on the right, think of these colors, shows you the percent of time that any pixel has observed water. So areas in red are extreme events where the water has existed for a very short period of time. So if you see these areas up here in the right and these very small areas of red, those are probably single time events where it probably just the water sat there for maybe 1 day in 17 years or 1 week. And these are rare flood events. The other areas that you see are where the lake has receded over time. So this area in green, the water has only existed there for 20 or 30% of the time. And the reason being is that this lake has receded over the years. The only area that has permanent water is the area that you see there in dark blue. So this is a really interesting time series. Imagine trying to do this if you had something that was, hang on just a minute, I'm getting a lot of noise in my background. Imagine if you had this, and hang on, I'm just moving to a different location. If you had to look at all of this data in 17 years worth of scenes, it would take an enormous amount of time to do this single analysis. We are also developing some algorithms based on the Sustainable Development Goals. This is a new algorithm we just created in the last month or two, and the Sustainable Development Goal 6.6.1 is called water extent. And for water extent, this is a case here in Lake Salonga in Tanzania. And this 4-year time period in Lake Salonga, there was a net loss in this lake of 3.8% of the water pixels. And so if you look at how this is done in the SDG process, this particular case, it's called an unmodified natural change. And what you see is the area in blue. I'm going to just use my pics on the screen. Anything that stayed water over the 4-year time periods is blue. Anything where the water has receded, the water that went from water to non-water is in red, and the areas in green have increased in water. So it's really interesting. You could do this year to year, and you can look at the water modification for any water body that you have. This is Lake Salonga in Tanzania. We also developed this algorithm to do a time series animation of the water area in a certain, in any water body. Look at the variation in the water over time, and you can see the months at the top. Lake Salonga changes significantly over the seasons. It dries down, you see, during the winter months. It increases in the spring, dries down again late summer. Now, what's interesting about this analysis is that it looks as if we know what the bathymetry is in the bottom of the lake. And the reason we can actually back out what that 3-dimensional bathymetry looks like is that because we know water, because of gravity, we know when the water is reduced and certain features are exposed, we can use that information as the water changes its spatial area. We can use that information to back out the bathymetry. So if a lake completely dries up like this one does, and then the water comes back into the lake at certain times of the year, we can back out all the bathymetry and know exactly what the volume is. Now, if a lake doesn't completely recede, we would only know the bathymetry information down to the point where it recedes. But this is a really interesting animation. So here's Lake Nakuru in Kenya. Interesting here is to look at the water history. If I just did 1 year at a time running this analysis, 2000, and then 12 years later, and then 2016, look at the difference in the shape of the lake. The portions in the west have significantly changed, and there's a lot of modification going on with the shape of this lake and its water extent over time. So these are a number of things that can be pulled out from some of these analyses. Water quality is an area that is of great concern. This is Lake Manyara in Tanzania. This is on the left-hand side is the maximum total suspended matter. This is a proxy for water quality. So suspended matter you can think of as the sediment lying in the lake at any given time. And as you see on the left, areas of dark colors, the dark reds, are areas of high sediment level. So think of that as dirty water, and the areas that are lighter in color are cleaner. And on the right, you can see the variability. So if you wanted to monitor the water quality in this reservoir or in this lake, it might be good to see a plot like this so that you would adjust your sampling scheme to take advantage of the variability. Why would you want to sample an area that has the same variability when you could strategically place your samples throughout the lake to understand what's happening in different portions of the lake. This is coastal change. I just did this analysis a couple days ago. This is Mombasa, Kenya, and this is for the last 15 years. Very interesting what you can see. Anything that has gone from water to land, which might be a good thing. What you see down here, this is by the airport in Mombasa. This is an area here where they apparently have built some new sandbars or some new structure here in this inlet. So this is an inlet coming off the ocean. This area here in green is new within the last 15 years, and everything in this structure here. Now, is that because the water has receded and these areas are exposed, or are these areas that were man-made? You can also see changes along the edges of the inlet. There's an area here in red where it's gone from land to water, so this area is now exposed to water, which it wasn't before. This area over here, I think, is marshland or possibly mangroves, and it also shows more water to land in these locations. So you can do this along the coast. You can see shifts in the coastline, changes in the coastline between any given years, but a lot of information can be pulled out quite rapidly. Again, all of this is only possible due to data stacked in a nice, clean time series representation. This one is really exciting. I just did this analysis yesterday, and this is Nairobi, Kenya. So we're working on some algorithms to try to better measure urbanization. And what I'm finding is there's a algorithm called fractional cover, which takes into account multiple bands of information in Landsat. And what you see is that the red in the two scenes reflects urbanization. I compared this urbanization layout to other urbanization maps online, and it was quite accurate. It was a pretty good representation. And of course, this is just a visual check. To really do this in detailed analysis, you'd want to go in and do a land classification and do some more depth of detail. But look at the difference here if you just consider this scale. In 2002, you can see the top, and on the right, 2017, the growth of Nairobi. The area footprint in red, using what we call a threshold, a fractional cover threshold. Basically, I just extract out the red pixels. The urban area has grown 6.7% per year in 15 years. The population at the same time period, I looked at several web sources, and it was about 4% per year. So what is this telling us? What this tells us is Nairobi is expanding its urban presence, its urban footprint, at a rate that's 1.7 times faster than the population is growing. So the population is moving out of the city and overtaking more land faster than the rate at which the number of people are growing, which puts pressure on the environment, and it puts pressure on general sustainability. So you might ask, what are those impacts? And to me, that's what the Sustainable Development Goals are all about, is understanding the growth of these urbanized areas in relation to population, and how is that impacting our natural resources and our ability to survive. Hold on, just popped up here. This is another interesting one I just did in the last 2 days. I was working with Tanzania. They were interested in some forestry, so I went and I ran an area over the Mau Forest in Western Kenya. This is an area that has undergone a lot of deforestation over the years. So if you go out online and you look at the most common place to find deforestation results over time is a website called Global Forest Watch. So I went out and I said, let me look at the last 15 years, 2007 to 2017, for Global Forest Watch over the Mau Forest. That is the result on the right. Anything that's black is considered a forest mask. Anything that's red has been deforested. look at the result on the left. The result on the left is the open data cube. This is a enhanced vegetation index threshold. We put this algorithm together. It's relatively simple, and I think you'll agree with me that the results are quite remarkably similar. So could we use an EVI threshold to find the latest in forest degradation or deforestation, or if you just want to call it a loss in dense vegetation? This absolutely will do the job and do a very good job. So I would argue, even though the Global Forest Watch does not publish their algorithm, he will not release it to the world, I can duplicate his results with an open source algorithm that you can all see on the left. Here's land degradation. 15.3.1 in the Sustainable Development Goal is all about land degradation. Well, what's happening in the Ankoba River in Ghana, which is illegal mining, is certainly land degradation. You can see the river on the left in year 2000. The part in the middle here, this little area in blue, was a little city here, a little urban area. So look at this river in 2000, look at the difference in 2017. These areas along here, this little horseshoe-shaped area and the areas that popped up along the river, all of that is illegal mining. So what happens in illegal mining is they go in and they deforest the area first. They drill for the mining minerals that they're trying to extract. Once those minerals are extracted in a period of a month or two, they leave the area. What comes up is the aquifer now has been exploited, and water seeps up through the surface. It comes up to the surface, creates a pond. All of the chemicals used in the mining process are now contaminating that water. And what you see here, these little red areas, are ponding areas that this is new water that is sitting there, but the water is heavily contaminated and the area has been devastated. It's the true limit of land degradation, because we've taken forested area and left behind highly contaminated water. This area alone has lost 13% of its dense vegetation, and this is the mask that we use on the right to identify that dense vegetation. So we can find this. We can find this over time. So here is the same approach. We've just recently started to look at Sentinel-1 radar. So what is the value of radar? There's not as much spectral information. Radar only has 2 bands of information. But the beauty of radar is it can see through the clouds. I never have to worry about clouds in my scene. Every time I take an image, I can see the ground. On the left is land change. This is this area that they're having a lot of problems with the illegal mining. On the left is a 3-year time period, 2015 to 2018, where the colors represented are different time periods. The water is all in shades of blue. All of the red areas are areas that have changed. The land has significantly changed. Much of this is due to illegal mining along the fringes of this water body. If you look on the right, this is just February to November of 2018. This is very recent information. And if you look at the pockets, this area in the top left, highly likely illegal mining, this area here, and the areas up here. So could these areas be just known deforestation and known urbanized extent growing? Possibly, but we're pretty sure, and at least the Ghana people have told us, these areas up here are illegal mining. Well, if we were to use Sentinel data and never have to worry about clouds during the rainy season, this is a tremendous amount of information that could be used for mining detection. Here's another thing that we did with L-band radar. Well, ALOS, which is a Japanese satellite, has been producing L-band radar data for quite a few years, and they've produced these annual Mosaic products, which is for the entire globe. So we're pulling these products into the African Regional Data Cube, and they'll be in there the next couple months. And so we will have an annual look using L-band, which is very, very good for identifying forests and large vegetation. So forests is ideally large vegetation. This is in Caquetá, Colombia. This is an area of known deforestation. So on the right is an image taken from the Global Forest Watch product. That was the one I showed you previously. And this is a 6-year deforestation, 2010 to 2016. The areas in pink were deforested. The areas in blue actually grew back. Those were forest gain. Look at the image on the left. This was nothing but a simple threshold analysis using a single band, the HV band, in the L band radar. So we compared the 2010 mosaic to the 2016 mosaic. Any area in red was deforestation, any area in green was regrowth. And I would argue this does a fantastic job of identifying and justifying the deforestation. So could you use L-band radar on an annual basis to look at the deforestation across the country? Absolutely. It would do a very nice job. So I'll end here and say for the future, these are some things that we're doing for the data cube. First off, we're adding new data all the time. So the Sentinel-1 and Sentinel-2 data will be in the system shortly. Same with that ALOS data I just demonstrated to you. Early in the coming year, this will be part of the cube, and we're continuing to update the current Landsat data. Ultimately, our goal would be to have the latest information on a monthly basis flowing into the cube. So if you go back month by month by month and look at the cube, it has the latest data. That's what you want in an operational condition. We're continuing to improve the operations and the use of Amazon cloud resources. It is a learning process and it's not easy. This is new technology. We're running into a few stumbling blocks. We've learned how to improve the performance, but we've also had some issues along the way. GPSDD, and Davis can tell you that they're hiring a new technical lead that will be able to support the African Regional Data Cube. So we will have someone in country that is trained and knowledgeable, that is able to talk with the users in the area and provide some technical support and some training. I think that's going to be an outstanding addition to everything we're doing. And then the last two bullets talk about how we're organizing our application library, how we're organizing a learning center and training materials. And I'll end, and I'm going to jump over to a web tool just to demonstrate for you. But if you would, copy down the address for that web tool. It's pretty easy to remember, tinyurl.com, ARDC-tool. This will get you to the African Regional Data Cube web user interface. And I'm going to demonstrate that for you. There's more information out on opendatacube.org. If you go there and go to the training link, you will find everything that I showed today. Much of this was presented to the Tanzania team in the last couple days. We have videos out there, we have documentation, training manuals, and quite a bit of information in the training area. So let me now jump over to this data cube and just show you really quickly how this operates. So when you go to this site, tinyurl.com ARDC tool, you come up here and you'll have to log in the first time you use it. You just create your own username and password. It's just so that we keep an eye on who's using it, but it's free and open, completely open. So if I went to tools, water detection, and I pulled up the Kenya cube, I can zoom in on the Kenya cube and find a water body. So let's, there was Lake Baringo, which we just did. Let me go down here and find, here's Lake Naivasha, if I said that correctly. I can highlight the lake. I will run a 17-year time series analysis on this lake while we're sitting here. So notice it starts running the task in the bottom left corner, and you can see it run. If you're the only one on the system, which is probably true for me right now, these analyses will run in a minute or two, but there's limitations. You don't want to take, you don't want to take an area that's the entire country. It won't run. It'll just, you'll be limited to something that's about 1 degree square is the max. So you can see here, this is about 0.2 of a degree square, and a pretty reasonable. So this is now analyzing 17 years of Landsat data, all stacked up, and it's going to show me a time series history of the water extent around Lake Naivasha for the last 17 years. You can change the location, you can change the extent, you can do so many other things. You can generate cloud-free mosaics from this tool. You can look at water quality from this tool. Many of the things I showed you in that presentation are possible with this tool, but the more powerful ones, like some of the land change data, that is not presently in the tool, but we're going to be adding some of the land change products in the coming months. So here it is. Product was done in about a minute's time. And you see a lot of variation occurring up here. Remember, the area in the center, if you come over here, there's a legend, tells you that the normalized water, the area in blue is water all the time, the area in red is very infrequent. Well, what if I zoomed in on this area right here? There's a little eyedropper tool in the top left, and I click on any spot on the map after I've created the plot, and I click on that. It is going to generate for me now a time series plot of that single pixel. I know exactly where the lat line location is because you can see it up in the top left corner as I hover. So what is it about this one location? If you look at the plot on the right, the bottom is just the mask of cloudiness versus clear sky. These are all the clear scenes on the top. These are all the cloudy scenes on the bottom. So you see it's about a 50-50 mix. There's quite a bit of clouds in some of these scenes. In the top right is the water, non-water. Here's what happens. Anything that's zero is non-water. Anything that's water goes along the top. Here's what's happening in this pixel right here. It looks like it's seasonal flooding, and the seasonal flooding started at about the year 2010. There was one instance of water existing over that spot. It came back again in 2012 for a couple instances, 2013, 14, 15. So it looks like since about 2012, it looks like every rainy season, this area right here has water. But prior to 2012, this was a dry region. And you can do this in any location. I can go ahead and say, well, how about this little red location here? There's a little spot right there. When did that experience water? I click on that little spot. I wait a moment, and it'll update the plot here on the right in a second. And come on, we'll give it a moment. And when this is done, this will be there it is. This little spot in red only experienced water back in 2002, 2003, and 2006 at about 4 different occasions, this little location. So if you think about what you're seeing here, you can run this for any spot in the country, and it becomes a flood risk map. Because if I'm looking at a low-lying area right here, and there might be a city nearby, I can tell you when the water existed in this one area. So you can do a lot of things. You can create cloud-free mosaics. So I can go to Kenya, and I said, you know what? I want a mosaic over Nairobi, and I can say I just want this cloud-free mosaic for 2017. I'm going to do this very quickly for you. That's 2017 to 2018. I'm going to look at a median pixel mosaic. And what I'll show on the screen is a sweer near red, which is a false color picture. So this is now saying I'm going through all of the data in 2017. And I'm going to create a cloud-free image of all of the data for 2017. And I'm going to plot it on the map, and here it is. So this is Nairobi in 2017. Now, this is basically a cloud-free image. If you looked at any of the individual scenes underlying this, many of them are cloudy throughout the year. But what I do is I create a median of all of the different bands, and I pull together this really nice, beautiful, clean image. Well, how can I use this? I can go to the Output tab, click on that mosaic that I just created, which is made up of 18 scenes over the year, 99.9% cloud-free. I can come over here and I can say Mosaic GeoTIFF, and I hit download, and it will download that GeoTIFF to my local computer, and I can go into my favorite GIS tool and analyze anything I want in here in great detail, never having to worry about clouds. I have a very clean image. I can do a lot more analyses, And what I might be able to do is I could compare an image in 2017 to an image in 2015 or 2014, and I can start to see change and things that are happening over time. So I will, I'll leave it there and just ask if there's any questions out there. And thank you for your time.
Thank you, Brian.
I see a few questions down in the chat box, and maybe we'll get to a few of these. Wow,
Yes.
quite a few questions.
Well, we could start with Wallace's question. It says part of the work is in disaster risk reduction in the semi-arid areas of Kenya, where we have projects. And my interest is how can this be applied in early warning systems for drought, for instance?
Right. So the way I would do that is if I knew a semi-arid area, I would probably go to the water detection algorithm, which I'm going to show you right here. And if there was an area here I was worried about the water, let's just say this is the location right here. Maybe all I'm concerned about is the last year, 2017. So I look at January 2017 to January 2018, and I run an analysis right here. So this is just doing a time series analysis of the water for just the last year over this location. And what, in terms of an early warning system, the way you might want to think about this is I could compare year to year to year. So I could do this analysis I'm doing here, I could run it in 2016, I could run it in 2017, I could run it in 2018, and I could look at the details. So notice there's not a lot of water out here. This is probably a pretty dry area, but if I zoom in on any particular area, I can see this area experience some water, and I can find out exactly when by clicking on this tool. And so you can start to look at the variability in water. There's a little, notice there's a little reservoir down here. That's water that existed for the entire year. So there's a number of things you could do in comparing the water. You could download this information in the output and take it into a GeoTIFF tool and do a comparison. So there probably are some things that you could do year to year. Let me go look at a few of the others.
Actually, there's a related question on the issue of downloading. Atamabiso asks about downloading a time series data for a particular latitude and longitude location from the tool.
Yep.
And I think you've essentially answered yes.
Yes, it can definitely be done. And if there's questions on how to do that, send me an email, or I will, if you can share with me an email list of the people on this call, I can send them a link to some documentation for training that would allow them to see this, allow them to look at a training tool. So I think if you go over to the Open Data Cube website, let me go there right now, the Open Data Cube website, opendatacube.org. You go over to the Learning Center. I'm going there now just to show everyone. There's a Data Cube overview, and here it is, ODC training site. It's in beta. There's a little link at the top, ODC training site beta. And I believe this is where, I don't see it right now. I'm gonna have to find out where they put the training from Tanzania just the other day, but I'll get to that. Let me go back to some of these questions here. So there was a question about Nigeria. No data for Nigeria yet. It is our hope that with Digital Earth Africa, we're planning to do all 55 countries, and hopefully within the coming year, there will be data for Nigeria. So imagine the amount of data to cover all of Africa. It's going to be a significant undertaking, but we hope that it happens quickly. There was a question about who are we working inside of Tanzania. We are working with Tanzania, a number of organizations, most of which are linked to the government. So the National Bureau of Statistics, I think it's the Ministry for Environment, Ministry for Agriculture. If you send me an email, I can share with you a list of people that were online in our training in the last 3 days. It was a pretty extensive list of individuals. We actually have an email list of about 40 or 50 people in Tanzania who are all working in this area. Download time series, that the answer was yes. So when you get to this result that you see here, if you go to the output tab, make sure you click on the output tab for the case that you ran. You can come down here and you can do water detection geotiff. And if I do water detection geotiff and hit download selected, I can get the details. If I just want the water percentages that are on the screen and I hit download selected, so I just did that now, I get a PNG file, which is just a high resolution image that you see on the screen. There was a question about using this tool for crop yield estimates for before harvesting. Well,
actually, we have two of those. Two people actually asking the same question on crop yield estimates.
So how might we do that? There's a number of ways that we do that. We're working on something right now. There's an NDVI anomaly tool. It doesn't work exceptionally well. I'm not in love with it. I would say a couple things. I like either spectral indices, which if you go to spectral indices, and Kenya, I'll do this while we're sitting here, and I'm looking at a crop area, I can plot NDVI, Enhanced Vegetation Index, anything I want for a given period of time. Remember, though, that Landsat has a lot of clouds in the scene. So, you know, on cloudy times, here's the problem. The growing season is also the rainy season in many instances, so you get a lot of clouds. So it's a very tough thing to do, but let's try and find an area. I'll go outside of Nairobi. Let's say there's some cropping maybe going on up here to the north. So if I just take an area here and I just do NDVI median pixel for the 2017 from, like, I don't know, maybe January through, go back, just January through May. So this is the median pixel January through May 5-month period, and there it is. That's NDVI. I actually prefer to use EVI. I think EVI is a better one, Enhanced Vegetation Index. If you go out on the web, you can find the calculation. So there it is. I could output that. I could come to this 7 scenes, 100% cloud free. So we got lucky. And I could come here and I could go to GeoTIFF and hit download, and I could download this GeoTIFF. I could compare the results of this one with the results of a prior year, and you might be able to do some yield forecasting. So precisely this question that you ask, there was a gentleman that came to me in Kenya. He was working in rangelands in northern Kenya, and I gave him a lot of time series Enhanced Vegetation Index data, and he was actually doing rangeland forecasting based on this data, looking at time series. So you could tie this information, if you knew what your crop yields were in prior years based on a certain vegetation index, you could take the vegetation index in the early parts of the year prior to the cropping, prior to when you're actually doing the harvesting, and perhaps build yourself a crop estimate. So it's very possible. The data's here. It's just a matter of how you want to use it. Let's look and see here. Well, this thing's jumping around on me. Let me see if I can make this a little bigger so I can view. It won't allow me to make the chat box any bigger. So let's see, there was, can we embed the visuals if I'm doing a story, or do I have to screenshot? Two different ways to do that. I usually screenshot. I've got a Mac, so I can take that. If you go to the output tab, and I'm on an output tab, you can do bandmath PNG or Mosaic PNG. So the Mosaic, so if I do the Mosaic PNG, that's going to be the background Mosaic. I'll hit download selected. I'm going to show you what it looks like. Bandmath PNG, download selected. If I go to my desktop, they'll be there. There's the band. Whoop. Let me see. It'll pop up real quickly. I'm just going to view it for you. There's the bandmath PNG. There's the Mosaic PNG. So you can create, JPEG PNG files for any of the scenes that you see here just by going to the Output tab. They can quickly download. I find if I make them a little larger on the screen so they're clear, I tend to like doing a screenshot. So let's see what else we have. Can I have a time series for polygons instead of a point? Okay, uploading shapefiles. We hope to add that capability soon. We have that capability in something called Jupyter Notebooks. So we do a lot of things with Jupyter Notebooks. So I'm going to show you really quick what I do with Jupyter Notebooks. You'll see here in a moment. Here's what a Jupyter Notebook looks like. So these Tanzania cases I was running, here's Tanzania Spectral Products. The way we build algorithms for everything that you see in this tool right here is we do it through these things called Jupyter Notebooks, where we actually have the ability to do all the code. In this code is where I have the ability to create multiple images and adjust the code, create output products. I'll show you another example that we just did last night for NDVI anomaly. So if you remember, I was showing you some of the land change products. There's a cloud, there's a forest mask, there's a land change mask, and then there's a forest loss mask. See, all of this is currently not in the user interface, and it's something that we're working on. We have within notebooks the ability to do shape files for defining a region. We do not have that yet in the user interface. It's something I certainly want to add. What I'd like to be able to add is when I go to the filter, instead of defining a latitude, longitude box, all I do is upload a shape file and it will crop out what I need. So I hope to add that in the future, but great question. But we have the ability to do that. So one thing you could do a bounding box that's larger than your shapefile. You could take the result out into your GIS tool, and in your GIS tool, you can mask it there based on your shapefile. So that might be one way to do it. Can we get a time series and embed it? Not sure what that means, Winnie, when you say embed it. You certainly, everything you're seeing here is time series. But if you're online and want to ask that with your microphone, I'll walk through that. And yes, are we planning to expand to other countries in Africa? Most certainly. Do you need partnering IT firm? We're looking at a number of options right here. Certainly, any option we choose has to be able to cover a massive amount of data and has to be able to manage multiple terabytes of data, and preferably in a cloud environment. So there's not many really large options out there, but we're looking at a number of options, Amazon being one of them, but there's other cloud networks out there that could possibly do it. So there's a committee right now. I'm on the committee. They're exploring what's called Digital Earth Africa. Digital Earth Africa is what we're talking about here. That is the plan to expand from an African regional data cube of 5 countries to all of Africa in the coming year. It's going to be a very large endeavor, multi-millions, probably on the order of $10 million a year type project. It's going to take many organizations and many decisions. So anyway, that's coming with time, and there'll be a lot of opportunities. Winnie, so time series and embed, if you're online and wanted to ask that question, please do. And I think I covered most of the questions. Yeah, go right ahead.
Thanks, Brian. This is really nice. For me, I'm trying to see, like the one. Okay, what I have in my mind is what you did for like Sugunga, the one in Tanzania. like showing from 2000 until 2017 how the lake has been depleted, or how it goes, how it has been over the years. I don't know if we can be able to get the same, and then we can maybe embed it maybe on a news site, like when you're telling stories. Do we have that?
Yeah, there's some.
Or it has-
Yeah, so in other words, like a time series animation.
yes,
Yeah, or
kind of.
even in a PowerPoint presentation, or when
Yeah.
you want to present it.
So a couple things that can be done. There's actually a tool, and I haven't really covered it, and I'll try to do it really quick here and see if I can't do this. So here's the Manyara Reservoir in Tanzania. So one thing that can be done here with this in the Manyara Reservoir. So I take a little area here, and I'm going to run a time series for, I'll just do it for a shorter period of time. Let me run this for like 10 years time period here. I'm going to run it from 2010 to 2017. So it's 2010 to January 2017. Up here where it says generate time series animation, I'm going to create this thing called cumulative percentages. And what this is going to do, it's going to create a time series animation of the cumulative water observations over time. I'll submit this and run it. Now, what happens is you have to be careful, because if you are running an analysis case like this with water observations, and you have the time series animation turned on, it takes a little longer to run. It might take 2 to 3 times. It's running pretty fast here for me in a moment, but it might stall at the end. I'm going to show you the product that's created when it's done. It's really quite interesting. And so in your presentation, you can take the final product on the screen. Obviously, we can output that in a, like in a JPEG, the color one. But the time series animation is the one that's quite impressive. So you notice it's stalling here at the end. It's because it's building the animation. So if this works here for us, it's always a terrible thing to do these on the fly, right? When we're going. So here it is. So here is this reservoir, which has some variability along the edges certain times. I come to my output tab, and in my output tab, you see there's 112 scenes that make up the data. And if I go down to the output, I've got water percentages. I can download that one. That's a PNG file that you see on the screen, but here's the key one. Water animation, I download. That's a GIF file, GIF file. So I'm going to go over, now that that's created, I go over to my desktop, and I'm going to click on this and run it for you. And can you see in my bottom right screen the animation running? That is an animated GIF, and just it's running right now. What it's doing is it's 1 second on your screen for every image over time, 1 second. So there's 112 images. So there's 112 time steps in this animation. And what's happening is you're seeing the water time series build up over time, and it's starting to slightly change. I think it ran pretty quickly. Actually, it's probably faster than a second. It might be like 1/10 of a second. So anyhow, you could create some pretty interesting animations. You can actually create an animation of the total water extent. So up here in the beginning in your filter, instead of cumulative, you can do cumulative observation, or actually do scene. And you create a scene animation, and it will go scene by scene and show you the extent of any water body. And so that creates a pretty cool time series. I've used these before in presentations, the animated GIFs, but I also just use that one, the color one, often, because if I use the color one combined with this right here, the normalized water percentage, the combination of those two give me typically what I need. I hope that answers your question. If you have some more questions about something you're trying to generate, just send me an email and I can help walk you through exactly what you might need to do. Are there any other questions out there?
Yes, maybe from me, my turn. I can throw in a couple.
Sure.
So from the land data, is it possible to get the kind of data we used to sometimes get from what do they call it? Remote spectroscopy or whatever it is, that allows us to see what the potential soil quality is, or chemical composition. The same way you were able to put a pin, to drop a pin on a point on a pixel and see what the water presence was like for that pixel over time. Is it possible to do the same thing with soil, very basic information on the soil quality?
Well, not so much soil, but let me show you what could be done. If I go to land spectral indices, we'll do one here for Kenya, and I pick a really small area. So let's go here in Nairobi, and let's say you've got a farm plot up here in an area here. So I'm just going to pick a really small area north of Nairobi, right here, and I'm going to run NDVI. Well, let's just run it for, I'm going to run it for a couple of years. So I'm going to run 2015. I'm just doing this on the fly, apologize. And I'm going to run it all the way through January of 2017. So this is 2 years worth of data. NDVI, it doesn't matter which index you choose for what I'm going to show you, but let's just say I do maximum NDVI. This is the product I'm going to create on the screen, which is just a maximum NDVI over the 2-year period. But what I want to show you is when you do the pixel drill on the plot, you're going to get some pretty interesting plots that show up on the right. So here's the details. But if I know a particular longitude location and I know it precisely, the first thing you do is put a window around the spot you want, then use the eyedropper tool in the top left to find, you see when I move this cursor around, you see in the top right, the latitude, longitude changing? I get this spot right here and I want to know what's happening for that spot. I click on that and you're going to see the plots that are generated on the right are every spectral index you can think of on the right. And this might get you what you need. I'll start from the bottom. This is the cloud and clear mask. 0 is cloudy, 1 is clear. There were a lot of cloudy scenes here in the rainy season of 2015 and the rainy season of 2016. So you only got some clear views outside of the rainy season. Rather unfortunate. If I come up and look at these indices, that's a burn index. Here's one here, soil adjusted vegetation index. This needs to be adjusted a bit, but it's saturated. And see what happens is it saturates at 1.0. This is soil adjusted. Here's the enhanced vegetation index, EVI. You get some really low numbers here. Not sure what happened. It's probably cloud contaminated. And then NDVI, which goes from -1 to 1. EVI tends to go from -1 to 2.5. You can see these time series plots. But when you have a lot of clouds in the scene, you start to drop out a lot of data. So you see what's happening is I'm only getting data here and here, even though it's producing some other results in between, like here, these are cloud contaminated. So these are not the best. So that's a cloud contaminated result. But you can see, you can start to look at time series variations for NDVI plots. And if you had an area that was not cloudy, you might be able to get at quite a bit more. So if I go back, let me just rerun this for 4 years instead. And maybe I can get a bit more. I'll run it right there. So this is going to be 4 years. So this is 4 years, little tiny spot. So it's kind of, you know, it's rather muted when you look at it because it's just probably a few pixels. But if that's my farm that I'm interested in, I could look at what's available and there's all the data available. So this is NDVI. there's probably some cycling going on here seasonally. This is 4 years worth of land. This area, this stuff down the bottom is cloud contamination, so it's a false NDVI. This is a more realistic NDVI. 0.8 is the peak of the vegetation. 0.2 is the dry period of the year. So obviously this spot is probably a grassland or some cropland. If you want to look more detailed, Enhanced Vegetation Index does a better job. This is Soil Adjusted Vegetation Index. Those are probably the three. But what you can see here is that there's a good bit of data, and it tells you a little bit about what's happening, but you have to consider the fact that clouds are a terrible thing, and they do have some impact in the data that you see. They contaminate the scenes a bit. I'll doubt that this pixel right here is actually 0 NDVI. It's probably got a little cloud contamination. So the key would be that I take this product here, and what I do is I go into the output and I actually download the GeoTIFF product, and maybe the GeoTIFF will give me a lot more information. So I hope that answered your question, but there's certainly a few things that you can do.
So I have one more question.
Yes.
This has to do with API access. So, for instance, if I have a pin, I have my latitude and my longitude.
Mm-hmm.
Is it possible for me to make an API call into the system with the coordinates and receive back whatever it is that I have requested with the API? For instance, the soil adjusted
Vegetation.
API, or yeah.
Right. Not now, but that sure sounds like a wonderful, wonderful thing. We do have an API for the data cube. So basically, the data cube itself, in the background, everything you're seeing here, this user interface, the Jupyter notebooks, they all operate through an API. So if you go and you look at the top of the Jupyter notebook, the very first thing it does is it loads up the data cube configuration. You see this line right here, and it calls an API. So there's a data access API. So yes, it is possible that this could be done. And you could write a script that calls an API, that calls our API and analyzes and gets at this precise data you want. So it would probably look like a notebook like this. You would create a notebook script that would run in the background and get you the data you want. We haven't really done that yet in an operational state. What I would rather see, since what we're doing here for the African Regional Data Cube is 5 countries, in time, when all this comes together and becomes more operational and more robust, I think there's a really tremendous opportunity to do things like these API calls, because then it'll be completely open, and you could write an API call against that. So it's possible to do it now. I have to talk with my team a little bit about, well, how does that get done? I think the way you're going to do that is through something like a Jupyter notebook. Someone asked about a recommended browser for the tool. I'm using Chrome right here. I haven't tested it on any others. I don't know how well it runs on Firefox or Internet Explorer, but I think my team uses Internet Explorer. I tend to use Chrome. It runs pretty good on Chrome. And someone said at the moment cannot run land use change in Tanzania. Stephanie, what do you mean by at the moment we cannot run land use change? Are you just trying to run a sample case and it's not running for you right now? Or is this a longer term request? Just curious. Any other questions out there? Did I answer your question there on the API call?
Yeah, that was fine. You did. On the land use change question, looks like that is something that Shadrach is exploring. Is land use is land use change? You already have that for Sierra Leone and some of this, because that's really the basis upon which the algorithms are looking at, for instance, deforestation, right?
Right. So let me show you my favorite.
Is it possible to use the the data cube to look at that from an agricultural perspective. Like if I needed to do an analysis of land use management for agriculture,
Yeah.
do the algorithms already exist for that, or would that require some coding?
So the answer is probably yes and no. You know, if you really wanted to do it powerfully, the way you do it is with something like this in a Jupyter notebook, where you have more flexibility over the tools that you use. And I build these things called thresholding, where I mask out certain ranges within a algorithm. So for instance, if I was looking here at this tool, and my product here on the screen is let me just pull this down for you, is an enhanced vegetation index. What I could do is I could mask out this product so that it only shows a certain range of EVI. I could then make that range of EVI coincident with a certain type of vegetation, and I could probably look at land use change. Let me show you my favorite tool for doing this. My favorite product, if you go to land fractional cover, this is a fantastic product. This fractional cover is an iterative algorithm that takes all of the Landsat bands and iterates it into 3 different types of things. And I'm going to show you in a minute. We're going to run one over Nairobi. It does a great job of distinguishing the difference between urbanized bare soil, photosynthetic vegetation, which is obviously croplands, and non-photosynthetic, which are non-croplands, basically dead vegetation. So let me look at here. This is going to be a mix in northern Nairobi of forests, urban area, and elsewhere. So let's just go. I'll start off with year 2002, and I'm going to do 1 year. So this is 2002, 1 year. I'll do median pixel, and this is now going to run, and hopefully there's not a whole lot of people running right now, because now that I've shared the tool, could be right. Oh boy, that ran fast. So look at what you see here. What you see in this tool, and I really like it because visually it's obvious. Areas in red are urbanized. They're bare soil. So basically this tool is in the top right is the legend. It is a fraction of, and by the way, this legend is labeled wrong. In the bottom left, that should be BS. I need to fix that. Bare soil is red. Non-photosynthetic vegetation, think about it as non-green vegetation, like dead trees, dead foliage. That's blue. Photosynthetic is green. So you can look at land use here, because certainly things are in green are going to be highly vegetated. Like we know that is grassland or farmland. We know this area here in red is urbanized. And we know this area here is a mix with the blue and red is a mix of urbanized and non-photosynthetic. So look what we have here. That's 2002. Let's go run the same exact thing for 15 years later in 2007. And you're going to notice changes. Same exact product. We're going to run it 15 years later. Look at the difference. So how can I toggle between the two? I'll show you. There's a little trick here that I use. I go to the output tab and I've run these 2 products. What I do is I click on one of them and I go down to the, oh no, I'm sorry, you go to the results tab. Click on one of them. You can come down here and hit show hide. And that's how I hop between them. So look on the screen now. 2002, 2017, 2002, 2017. I would suggest that I could definitely show land use change between these two, because areas in red are bare soil that have grown, and bare soil is usually coincident with its term is bare soil, but it's basically an area totally deplete of vegetation, which is common with urbanized areas. So look at the difference in the middle, completely urbanized. Matter of fact, there's a road, it looks like a road going through the bottom in 2017. That road did not exist in 2002. You can also see areas that right up here, look at this area right here. It had some urbanized area, it had some blue in there, but it wasn't very green. Look at it in 2017, it's heavily cropped and it's a really bright. Look at this area down here in the bottom right. That area is pretty much the same. So this area here has been vegetation the entire time, and you can see some great changes. So look at this area right here around this lake. So the lake is black. It was a cropland, and now it's significantly changed. So you could take these two products, take the output tab in a GeoTIFF, pull them out into your favorite GIS tool, and be able to compare these two and do your own quick analysis of land change. So I hope that answers your question, but I love this fractional cover product. It does a fantastic job of visually as well as mathematically allowing you to do the land change. And the way I did that urbanization product that I showed you, this product right here, this urbanization product that I showed you earlier on the screen right there, that's the fractional cover product. And all I did was threshold out the red pixels and count them. And I counted the red pixels, and that's how I determined the area change between these 15 years. So there I am back again. I hope that is what you were looking for.
And I think it does provide. I mean, at least for me, I'm not sure about Shadrach, but obviously he's very excited about that fractional cover product as well. Wellington asks whether you can use R to analyze.
R can be used, but you'd have to use it through the programming interface here. I believe there's some people who have dabbled with this or have to use it through the API. We use Python. That's all the scripting you see here. This is all Python code. But the background, just to put it in perspective for those of you mathematically or understand this, it's all a GDAL interface. So you can use any GDAL commands to interact with the cube through the API. So it is possible to use R in this. I just don't know precisely how. So it's something we'd have to ask my guys about. Where can one get the Jupyter code for the tool? Well, the Jupyter code for all of this tool, I can give you, for those of you that have the skills to do Jupyter Hub programming, I can give you, for each of the countries, we have a Jupyter Hub interface, and it'll look like this when you get to it, a file structure. This is mine, my personal one that I use. There's one for Tanzania, there's one for Kenya, there's one for every country. So for James Mwangi, send me an email. I will give you access to the Jupyter Hub for Kenya, and I will give you some instructions on how you can use it and play around with it a bit. And Stephanie, yes, I'm glad you like that fractional cover product. I love it as well. It's one of the best it's a multi-parameter, a multi-band product. It's really fantastic. I think it's better than any individual index because like NDVI only uses 2 bands. Most of your normalized difference indexes only use 2 bands. Well, the fractional cover is an iterative tool that uses all 6 Landsat bands, really does a nice job, does a really good job. And you could see visually it made total sense, what the difference is there. So anybody out there that's can do a little Python programming and wants to have access to Jupyter Hub, please send me a separate email and we can do that. But I'll have to urge some caution there in that there's a lot of power and things that can be done here. So we have to be careful in the size of the jobs that we run and so forth, because we run into memory issues if we pick regions that are too large. But it does a nice job. You can see, and all the products are embedded in the tool, and I can share with you a number of algorithms that I just did a training session for Tanzania. I'll send those of you that want to see more about this, when you send me an email, I will send you a link to a video of my training session with the Tanzania team just yesterday, where I walked through how to use the Jupyter notebooks and how to use these two algorithms for land change. Really quite exciting information.
Excellent.
Anybody else?
I have one more question. While it's people think about any additional questions they may have, and this has to do with frequency of update for the data. How often is this data refreshed?
Well, this is Machiri talking, correct?
Yes, it is.
Okay, very good. All right. Well, the bad news is right now it's not being updated often at all. Matter of fact, the data we have in the current 5-country data cube only goes back to like early 2018. And the unfortunate thing is that we haven't put the proper people and tools in place to have it automated and get it updated. My team right now is downloading all of the remaining Landsat data for 2018. By probably in a month's time, all of the 2018 data will be there. In the perfect world, if this were automated, my goal would be every week the cube would be updated, because every week there are Landsat Sentinel-1 and Sentinel-2 scenes being taken. They're being processed about every 24 to 48 hours after they're taken, and there's no reason why you couldn't automate that and bring it in. So I think what we'll find is that we have some updating to do now to get us current through the given year. We'll probably go to like a monthly update starting in early 2019. And then once the full African Digital Earth Africa gets in place, there will be automation added to all of this. Someone asked about, is there anything for sharing open data in Cameroon? Nothing yet for Cameroon, but obviously it will be part of the Digital Earth Africa coming in the future. So it's funny when I show this to anybody else outside of that 5-country network. There's a tremendous demand for this information and this kind of data, and I hope to get it in your hands as soon as possible. And this is why I think Digital Earth Africa will be a great success, because there's a big demand for this kind of information. If I'll tell you a quick story. I was talking with someone in Tanzania. We were doing a training a month or so ago, and I was showing him this product that we have right here, and I was actually creating a cloud-free mosaic for him over a location where we were comparing year 2015 to 2017. I developed the cloud-free mosaic in a matter of 1 minute, 2 minutes on the screen, showed him how to download the GeoTIFF, and he paused and said to me, "What you just demonstrated takes me more than a month to do on a typical basis." So the process of downloading scenes, extracting out the clouds, pre-processing the scenes into a good surface reflectance format, all of that is done in the background with this cube approach. And I can't tell you the efficiencies that are gained by having all of this stuff stacked in a nice, clean data cube. That's the beauty of everything you're seeing here. It's really an incredible resource of data that would otherwise take you orders of magnitude more time.
Yeah, excellent. Are there any other questions?
There's a question out there. Yeah.
Yeah, I'm just wondering, okay, for the non-tech people who really would like to do, like we have a journalist who would like to work on this. I don't know, would you have time to take them through, or how would this work?
Yeah, I've had a number of journalists come to me. I've done a bunch of interviews, and articles have been written about this. I just did one yesterday with Amazon, where I had an interview with an Amazon journalist who wanted to know more about how we're using the data cube, around the world, and what are our intentions, and what is the impact of this kind of information, especially open data, because all of this is only possible because the Landsat archive is open and the Sentinel archive is open. Imagine if this was 2006, none of this would be possible, because in 2007 the data became open. So feel free to contact me, and if we can do an interview. It could be somebody from my team. It could be someone from, we have folks in Australia and in Switzerland that are using the DataCube concept regularly. Australia is producing some amazing products, and Switzerland is producing some amazing products. Those two countries can talk more about the use cases and the impact. I'm one that can talk to you more about what the intent is and what kind of analytical products we have, but I can point you in a direction to talk to a number of people.
Thanks.
Surely.
Excellent. So it looks like we maybe have run out of questions. With a few minutes to spare. So I'd just like to say this is. I'm hoping it has been as informative for everyone as it has been for me, and to see what possible opportunities there could be for integrating the DataCube with the efforts that we currently have. For those of us from countries that are not part of the initial 5 countries, such as Cameroon, Nigeria, and others, I'd suggest that we reach out to our colleagues in government, let them know about the DataCube and what it could do for them, and let's create some demand. I'm sure the global partnership would be inspired by seeing requests coming in from countries, and I know there already have been some countries that have reached out saying we want to be part of this. But I think it helps when all of us who are probably not working in government but are from outside of government can also weigh in and encourage our governments to participate and be part of this. When the data becomes available, it's useful for all of us for the work that we're trying to do. I know within this group we have people working on disaster risk reduction and resilience. We have people working in agriculture and natural resource management. And I think in those spaces we're very aware that the state, the government, public sector can't do the job on its own. These things require all hands on deck, and the DataCube provides us with a resource that we can use to get the job done. So let's put some advocacy muscles into this and encourage our governments to reach out and show interest.
Sherry, yeah, thanks for that. Just to quickly mention, maybe in response to Winnie's question, I mean, one of the things that has really come up again and again is for the non-tech community, how do they really make use of some of the products that are coming out of the ARDC? We are integrating our communications and engagement strategy around the ARDC, and what this is going to be doing is to look at potential partnerships with organizations and institutions that do more of visualizations, and also proactively thinking about the packaging of different messages for different audiences. So whatever we are doing for an advocacy organization would be different from what we'll be doing for a policy maker. So all those are, we really want to test the infrastructure first, see some of the products coming out that Brian is showing. And once that is done, then proactively engage with these products and see what the response is. For example, in Tanzania and in Ghana, these questions are coming up, and in a way, people from national space agencies, national security agencies, ministries are asking us, okay, this is the problem I'm trying to tackle. How do I present this data in a way that will excite my minister, for example? And of course, then we have to work together to figure out, okay, what does your minister consider to be most important, or what would appeal to him, and then how do we work backwards to package this in a way that then responds to that that specific need. Thanks.
Yeah, excellent, and that's quite true. We'll also be on the lookout to see how to support with capacity building different communities that are attempting to use this data. And I'm glad to hear that GPSTD already has some significant effort going into that. So at the Africa Open Data Network, a number of things that form our key objectives, other than advocacy and research and peer learning, it's facilitating technical assistance to governments and capacity building for those working on development and want to use open data to do it. So I see collaborations. So we'll continue to build those out. There's a video. This has been recorded. Brian will share it. We'll share the link with everyone, so that those who signed up and weren't able to attend will also be able to learn and find out more about the Africa Regional Data Cube.
Sherry, I have a question for you about the process. Do you have everyone that signed up? Do you have emails for those people online? Because if you have the email list, what I could do, I could send you a PDF of my charts, and I could send you a link to the YouTube recording once I upload it, and then perhaps you could share that with everyone on your distribution list. Would that be the best way?
That will work really well.
All right, I'll do that. I'll get that to you today.
Excellent. So any parting comments, Davis?
Arthur asked at the end about sharing the PowerPoint. Yes, I will definitely send that along.
Yeah.
Just to thank you, Mushiri, and of course Brian, but especially Mushiri, because of I mean, for us really the focus over the last couple of months, like I've said, is to delve deeper into, you know, beyond the infrastructure and beyond the data. What is it that would be most useful? And for you to bring in other data communities proactively, I think is a great way for us to engage. And all the questions that are coming from these different groups and individuals will definitely help us to refine the product. And of course, through the public user interface, we encourage all of you to interact with the data. And if you you know, working on specific algorithms, or there's some code you're developing that you think might be useful, whatever we have in the Africa Regional Data Cube actually is you know, it's more or less an aggregation of different methods, tools, approaches that are being tested elsewhere and being applied. And what we're trying to do then is to ensure that we make these resources as widely available to many others as we possibly can. And with your support, I'm sure we'll be able to do it. So continue engaging with us. And thank you so much for creating time to join us.
All right.
Yeah.
Brian,
I'd also like to offer my thanks, Mashiri and Davis. Thanks for pulling this together. I think, you know, a webinar like this with a broad audience like we had today is really outstanding. It brings questions from a technical audience. It brings questions from non-technical. It's really great to have a variety of people engaged in a webinar like this, and we look forward to working with you, and we look forward to engaging more with the Kenya community.
Oh, welcome, Brian, and thank you for making the time. Thank you, Davis, GPSTD. We look forward to doing more of this, and we thank everyone for making the time to be part of this webinar. We have more planned in 2019, so please do stay tuned. And it actually is our last webinar for 2018 as the Africa Open Network. So if there isn't any last song, poem, I will bring this to an end and say thank you very much. Remember, you can follow us on Twitter. We are at Network for Data. You can follow GPSDD on Twitter as well. It's Data for SDGs. The website dataforsdgs.org for GPSDD, and for AODN, it's africaopendata.network.org. Please click, join our community online, sign up to our newsletter, join our Google groups. Let's stay in touch. Let's continue engaging, and we look forward to doing amazing things, moving our development agenda forward rapidly in Africa using data. So thank you very much. Have a fantastic weekend. And in case I don't bump into you on a street corner somewhere, happy holidays and a happy new year.
Thanks, everyone.
It was all right.
Thanks, everyone. Bye-bye.
Bye now. I'm going to close it all down.